Welcome to Spoto's online quiz. Today, we'll explain real certification exam questions to help you prepare with confidence. Questions 1. You're working on a project and are working with personally identifiable information, PII. What's the best approach to take when it comes to collecting and using this data? A. Use noise reduction techniques to reduce all forms of data noise. B. Implement a new data privacy policy. C. Store the data in a data warehouse. D. If this data is not needed, use data anonymization techniques to remove it before feeding to models. You have 15 seconds to answer. Answer, D. This answer is correct because it aligns with the core data privacy principle of data minimization. This principle mandates that organizations should only collect and process personal data that is absolutely necessary for the specified purpose. If PII is not required for model training or analysis, the most effective approach is to remove it before use. Data anonymization is the technical implementation of this principle. By using techniques like hashing, masking, or aggregation, you sever the link between the data and an individual's identity. This drastically reduces the risk of privacy breaches, unauthorized access, and non-compliance with regulations like GDPR or CCPA, while still allowing the non-sensitive data to be utilized for its intended business purpose. It is a proactive, technical control that directly mitigates risk. Questions 2. You're being told by upper management that you need to manage a new AI project. You need to determine the AI project fit to make sure you're actually solving a real business problem. During phase I, business understanding, you should consider at least one of the following. Select all that apply. A. Explores a proof of concept for an AI project. B. Enhance revenue. C. Solves a previously unsolved problem. D. Improve company competitiveness in the market. E. Has the cool factor. F. Solves an already solved problem but does it better and cheaper. You have 15 seconds to answer. Answer, B, C, D, F. During the initial business understanding phase, the primary goal is to ensure the AI project is firmly rooted in tangible business value and aligns with strategic objectives. The project must have a clear why. Enhancing revenue, B, improving competitiveness, D, and creating more efficient, cost-effective solutions, F, are all fundamental business drivers that justify investment and guarantee a return. Solving a previously unsolved problem, C, represents a significant opportunity for innovation and creating a distinct market advantage. Conversely, the cool factor, E, is a poor justification that often leads to projects without a real-world purpose. A proof of concept, A, is a technical validation step that occurs after the business problem has already been identified and deemed valuable enough to explore. Questions 3. Your team is working on a new loan decision model that takes a number of factors and data points into consideration and then automatically approves or denies a loan. After a month in operation, someone does a review and notices that the system is denying a large number of loans from a certain demographic when all other factors from people in other regions, such as age, salary, and credit score, are the same. What is most likely happening here? A. Biased data sets leading to algorithmic discrimination. B. Generative AI models hallucinating data results. C. Nothing is wrong, algorithmic decisions will never be 100%. D. Data privacy issues leading to data sharing concerns. You have 15 seconds to answer. Answer, A. This scenario exemplifies algorithmic bias originating from the training data. Machine learning models for tasks like loan approval learn patterns directly from historical datasets. If this historical data reflects past societal biases or discriminatory human decisions, e.g., fewer loans were historically approved for this demographic, the model will codify and automate this prejudice. The algorithm has likely identified the demographic feature, or a proxy variable like zip code, as a statistically significant predictor for denial. Consequently, it systematically penalizes applicants from this group, even when their individual financial profiles are strong. This is not a random error but a learned, systemic flaw in the model that results in algorithmic discrimination, perpetuating and scaling historical inequities. Questions 4. Your team is tasked with selecting an algorithm for a supervised learning classification project. Which algorithm might you choose? A. Gaussian mixture. B. Q-learning. C. K-nearest neighbor. D. K-means. You have 15 seconds to answer. Answer, C. The selection of K-nearest neighbor, KNN, is correct as it is a foundational supervised learning algorithm used for classification. In a supervised context, the algorithm learns from a dataset containing labeled examples, i.e., data points with their corresponding correct class. KNN embodies this principle by classifying a new, unseen data point based on the majority class of its K closest neighbors in the labeled training set. The other options are incorrect for this task. K-means and Gaussian mixture models are unsupervised learning algorithms designed for clustering. Their goal is to identify inherent groupings in unlabeled data. Q-learning belongs to an entirely different paradigm, reinforcement learning, where an agent learns to make decisions by receiving rewards or penalties, not by training on a pre-labeled dataset. Questions 5. During CPMAI Phase 2, it's important to not only understand the sources of your data but also what data is required for training as well as identifying the features that are required. When looking to gather data, what approach is best when determining how much data you need? A. The Goldilocks approach. B. The less is better approach. C. The more is better approach. D. There is no correct approach. You have 15 seconds to answer. Answer, A. The Goldilocks approach is the most effective strategy as it focuses on finding the optimal balance between data volume and project constraints. Simply collecting more data can lead to diminishing returns, incurring significant costs for acquisition, labeling, storage, and computation without proportional gains in model performance. Conversely, using too little data results in underfitting, where the model fails to capture the problem's underlying patterns and cannot generalize to new, unseen information. The correct approach is to acquire just enough high-quality, relevant data to enable the model to learn effectively and achieve the desired performance metrics. This ensures an efficient use of resources while minimizing the risk of building a statistically weak model, making it a pragmatic and technically sound strategy. Question 6. You have been receiving customer data for the past 6 months. However, recently you noticed that this data has drastically changed due to the upcoming holiday season. What seems to be taking place? A. Lack of stakeholder support. B. An incomplete milestone list. C. Data drift. D. Model drift. You have 15 seconds to answer. Answer, C. The correct answer is data drift. This phenomenon occurs when the statistical properties of the input data, which a model is trained on, change over time. In this scenario, the drastic change in customer data due to the holiday season is a classic example of data drift caused by seasonality. Customer purchasing habits, demographics, and engagement patterns shift, altering the underlying data distribution. This is distinct from model drift, or concept drift, where the relationship between input features and the target variable changes. While data drift can cause model drift, the primary issue identified in the question is the change in the input data itself. The other options, lack of stakeholder support and an incomplete milestone list, are project management issues and are unrelated to the statistical changes observed in the data. Question 7. A team is getting ready to begin working on a ML project. They need to build a data preparation pipeline and someone on the team suggests they reuse the same pipeline they created for their last project. What's wrong with this suggestion? Pipelines are model operationalization need specific. Pipelines are pattern and model need specific. Pipelines are pattern needs specific, so as long as it's the same pattern then you can reuse the pipeline. There is no issue. Pipelines can be reused as needed between projects. You have 15 seconds to answer. Answer, B. The suggestion is flawed because data preparation pipelines are highly tailored to the specific project. They are pattern-specific, meaning the pipeline steps, e.g., handling missing values, scaling, encoding, are designed for the unique features, distributions, and quality of a particular dataset. Reusing a pipeline on a new dataset with different characteristics would be ineffective. Additionally, pipelines are model need specific. Different machine learning models have distinct input requirements. For example, a linear regression model benefits from normalized features, whereas a tree-based model does not. The pipeline must transform the data into the precise format expected by the chosen algorithm. Since a new project likely involves a different dataset and potentially a different model, a new, custom-built pipeline is required to ensure data integrity and optimal model performance. Don't want to miss any exam content? Visit the SPOTA website now to take a free practice exam. Or add us on WhatsApp for everything you need to know.